Hey everybody, welcome back to Gideon Stuff. Today's video is going to be a little bit different. I'm going to be walking you guys through some adventures that I have. As a lot of you know, I'm a geologist, and one of my favorite pastimes is exploring abandoned mines. I enjoy this for a couple of reasons. Number one, I like the history and the mystery of finding and exploring these old mines. Number two, it's an adrenaline rush. It's a lot of fun, heading into the unknown, seeing what you're going to find. There's definitely a risk involved, and I like that risk. And I also just enjoy collecting minerals, right? I find a lot of cool minerals at these mines, and I'm really into that. So this is something that I do as often as I can. This is one of my go-to weekend activities, is finding these old mines and exploring them. There's a couple of ways I do this, right? I first got into exploring mines a few years back. The very first mine I ever went into was actually a mine that is on some property that my family owns. The mine was dug by my great, I'm not sure how many greats, I think it's three, grandfather between 1898 and 1902. And they continue to take stuff out of there. It was not a very profitable mine at all. But I went down in there a couple of times. In fact, I think I have a video on the channel. I think I tested a flashlight down there at some point. Very, very cool. That kind of got me hooked. And then the next mine I went into actually happened because I was working on a project and I was looking at a bunch of maps of this area that I was wanting to study. And I'm reading lots of papers on the geology of the area, and I found this map from, I think it was 1948. And they had a bunch of different mines listed on the map. And a lot of these mines weren't listed on modern day maps because the mines are inactive, they're shut down, there's no need to go to them anymore. But I thought, what the heck, let's see what this is all about. So I went to those mines, and I had a lot of fun exploring them, and it's all been downhill from there, right? So in today's video, I'm going to be showing you, depending on how I put this video together, me exploring one or more mines that I think are really, really cool. I take a lot of video footage when I'm down in these mines because it's fun, it's awesome. And I've been kind of looking for something to do with this footage. And I decided that instead of sticking it into other content, let's just make a video about exploring mines. So I'm going to stitch a lot of this video together. I'm not sure how cohesive this is going to be, but I'm going to do my best to kind of edit it into something watchable, and hopefully you guys enjoy it. So the first mine that we're going to explore is some footage that I took more than a year ago, and it's actually stitching together 3 separate visits to this one mine over the course of about 8 months. And the first time I went there, I was still a very fresh-faced and new to the hobby explorer, but hopefully you can see as it progresses, I get a little more experienced. I've definitely done a lot more with exploring mines than I ever thought I would. I've rappelled into mines. I've gone into places that I just never thought would be accessible. But yeah, this is some kind of early stuff. So we're going to go ahead and roll the footage. I hope you enjoy. Hey guys, so I'm out here in the middle of nowhere right now looking for an old mine. And I made a short about this, but I want to make some longer form content to throw in with another video where I can talk about it a little bit more. My poor truck, holy cow, I've drug it over some crazy roads. Anyways, I'm looking for this mine that was abandoned about 100 years ago. But in this little arroyo here, I feel like I'm getting pretty close. Look at how sparkly and multicolored all of the rocks in this little arroyo are. We're looking at some alteration, folks. And I think I've identified a big old fault through here. Plus, it looks like there's a little bit of a cave or something up there. I'll show you in a sec. If we look up there, see where that red stripe is? Just up there, it looks like there's a little cave or a tunnel or something. It might be a natural cave, or it could be a mine that someone started digging. I'm going to run up there and see what we're looking at. This sand in here is really, really cool. We've got like this kind of pinkish red and then this mustard yellow. Very, very cool. We're going over here. I'm not sure exactly what this formation over here is. It's predominantly sandstone. I just saw something sparkly. It caught my eye. I think it's a little feldspar. Yeah. Ooh, look at that. Look at that. It's a big old feldspar crystal. These big feldspar crystals are weathering out of Proterozoic bedrock. I know there's some Proterozoic granites through here. They're being washed down from somewhere else. But yeah, I don't know what formation this is. Some kind of sandstone. I'm guessing it's probably... I don't know. It might be Bliss sandstone, but I don't think it is. Actually, it might be Bliss sandstone, which is like a Cambrian sandstone. This stuff here, though, this is Palm Park. So, you see this big chunk in here? It's a big, not xenolith, what's the word I'm looking for? A big lithic fragment. Had a little bit of a brain fart there for a second. This here looks like a lahar flow to me. So this is a volcanic deposit. Basically think about it as a volcanic mudslide. Picked up chunks of other rock as it was coming down. This is the Palm Park andesite. And this is about 45 million years old. So if this stuff here is Bliss, which I'm thinking is a little more likely, then we've got a little bit of a fault here that's putting this super young stuff against the super old stuff. And that fault would also explain all the alteration we've been seeing. So, probably a very, very good spot to find a mine. Alright, so I'm getting ready to head up to that little cave I saw. Park my truck here next to this Palm Park surface. I'll be honest with you, getting out of here is going to be very hard. This is a very narrow little arroyo. Probably gonna have to back out the entire way. And it's a rough road, so it's going to be tricky, to say the least. According to the old maps I have, this road should continue for about another 1.5 miles to the mine. But these are kind of crappy maps, so I'll probably walk down this way a little bit. If I can find a better spot to pull, like turn around, I'll take my truck down there. But yeah, this has been fun. Let's go ahead and scramble up that hill. Oh yeah. Look how pretty that is. Look how dark and vibrant this stuff is. It's very, very unconsolidated. Look at that. Oh my goodness, it's wonderful. Absolutely wonderful. Very, very cool. Alright, well here's that area I wanted to get to. Looks like this softer, colorful stuff just kind of gave way in the heavier, massive sandstone. Fell down. You can see this big block used to be up there. Gorgeous view though. There's my truck. You can see the road. I guess we'll follow it for a little ways. See what we find, but yeah. Awesome spot. Well, I think we're getting close. There's something that looks like it could be related to mining. Had to leave my truck behind because I don't think it would make it up what is left of this road. This is yeah, this is pretty gnarly. You'd need something with a little more oomph than my poor little pickup truck to do this. Looks like I came down on top of the... Oh, shit. Cactus went right through the bottom of my boot. But, I can feel the spine in there. We'll have to deal with that. But look at that cool quartz. Oh, yeah. Oh, shit. Right in the bottom of my foot. Damn. Whoo! Yeah. Those are big ones. Ouch. All right, let's take a seat here. Oh, wow, look at that. That's pretty. All right. Yeah, there's a lot of cool stuff here. We'll have to
add things to the backpack. Ooh, look at that. Ooh, I love that color. Focus, camera. There we go. All right, now let's deal with my very in pain foot. You know, I need to replace my Leatherman that got stolen, because this would be a great job for it. Oh, this is gonna hurt so bad. Ooh. Focus up, camera. Look at the blood on the end of them things. All right. Ouch. Luckily not all of these are in my foot. Oh man, but that one is. All right, now I got my foot fixed. Got some ointment on there. Ooh, I'm gonna be limping all day today. That sucks. But what I was saying before I stepped on a cactus, looks like I came down on top of the mine. I see a little structure right there. And then over there, we got a big old pile of wood. And so I think I'm standing on top of the mine. We'll get down and look at it from the back. There's that fault right here I'm kind of lined up with. So yeah, let's see what we're looking at. All right, so we found a mine. But this is nowhere near as large as I was expecting this mine to be. Look, there's the lid from an old dynamite box. I was expecting something a little larger. Looks like we might have a pretty big system in here though, so I'm gonna look around and see if I find any more. Should be interesting. Yeah, guys, I need to invest in a GoPro. Ooh, look at that. Pretty quartz. Put that there for now. Oh my gosh. Got my flashlight out, but I don't think we'll need it. Turn it on just for a little bit extra light. Oh my goodness. Yeah, this is it. Focus, camera. Got support beams. Yeah, it's a good thing I didn't try coming in from the top like I was planning. And we've got a shaft that goes down right there. A long ways, it looks like. Oh, I see the bottom. You guys see the bottom? Oh my goodness. This may be the coolest mine I've ever been in. Oh wow, look. That's an old cart rail. Oh my goodness, and that goes back a little ways too. Yeah, here's old tracks. There's the other rail right there, and this one's been popped up. Look at that fluorite. Oh my goodness, ain't that pretty? There's another big vein of it. Little hole. There's the tracks again. Oh, and there's something off that side. Do I? Yes, I do. I'm Gideon, of course I do. Man, look at all the little fluorite chunks. I have to come back here and pick some up. Man, these walls are just covered in fluorite. There's a little opening there into another chamber. Let's see if I can find a different way in. Yeah, look at that. And look at these tracks. Those are so freaking cool. Oh my gosh. Man, this wall, the ceiling is just absolutely covered in fluorite. Yeah, I need a GoPro. Oh my gosh, you're kidding me. Oh my goodness. Oh, I hope I can get into there. This is so cool. All right, let's see if we can find some way to access those other corridors I was seeing. Oh my gosh. This place is ginormous. Holy crap. Good heavens. I have never been in a system like this before. My goodness. I think we'll go that way first. Now, obviously, when you do stuff like this, you gotta be really careful. Wow, that is a gorgeous chunk of fluorite. I'm gonna set that right there and get it when I come back. Ooh. Is that the little thing I looked up through? Is that the window that? I don't think so. All right, here we go. All right, so that one just kind of dead ends because I'm a big dum-dum, but now that I'm here and I know, I'm a little goober, that's right. So yeah, last time I was here, I said this tunnel didn't go anywhere. It does, kind of.
There's a lot of stuff. I want to see what's in there. Break me the elevators.
Not a whole lot, but it's cool. Got our dynamite holes. It's very echoey in here. Holy cow. Do you hear that reverberation of my voice?
Yep.
It's like buzzy. That's cool. Yeah, it doesn't look like the fluorite vein really goes back here too much. Very cool. I wonder who stuck that in there. I wonder if that used to be a bat's home.
Oh yeah, you should see over
Poor little bat. There's that little hole I was looking up through. Looks like we've... What is going on over here? I think that used to be a chute. It's had a partial collapse. Interesting. We may not want to go too far down here. Looks like there's something over there, but I think it's fallen in. Look at that cute little bat. So yeah, that tunnel does go further, but it looks like we've had a collapse, so I don't think I'm gonna go that way. Ooh, cool breeze coming through.
something built up there. Maybe we'll crawl just a little bit closer. Alright, I crawled in here on all fours. There's another tunnel. It's a big chamber. It looks like it goes off that way, but I don't think I'm going to get in there. That'd be a pretty awful place to get trapped. So, then we're going to head back. Man, it looks fun in there, though. Alright, so I finally came over the little collapsed area. I've got my friend Janelle with me here for backup. And it just keeps going. There's more rail. Alright, well, I made it to the end of this tunnel. There's a lot more rat sign down here. Yeah. Rat crap everywhere. There's more tracks. It looks like there's something else over here. I'm not sure if this is going to be passable or not. Oh yeah. Another tunnel down there, but I think it ends right there. Oh, unless it turns. Now, what is this? Huh. Interesting. There's another little tunnel here that goes off to the left. I'm gonna see what it does. I think it just ends there. Unless it turns off to the right. Which I don't think it does. Interesting. Oh well, that goes up quite a ways. I'm alive. Oh, what a spot. What a spot. I can't believe I didn't see all these bats.
Bro. A whole army of them.
Yeah. Holy crap. Look at all these little cute flying mice. All right, well, there's other places we can go. Back the way we came. All right. They are cute. They're very cute. All right, so I climbed up to here. Pretty cool, that chamber we went in. Then went this way to the collapses. Over there. We got something here. I wonder if this little chute goes down towards that first little chute we saw. And man, it still keeps going. This is incredible. This is absolutely incredible. You know what? I think we're going to go outside right there, and we're going to go around and see it come in through one of the other entrances. Well, guys, I think I've explored as much of this as there is, but it looks like there's another spot across the valley. I know what you're thinking, Gideon, why are you shirtless? I ran out of pockets to put my fluorite in, so I made my shirt into a little bag. But I did want to show off. I mean, look how cool that is. And going back there, it just kind of dead ends. It looks like if I were to go up there and over, there might be another shaft, but I'm not sure I'm going to do that. And If I do, I can probably access it easier from the top. That's what I'm assuming. Be one hell of a nasty fall, right? Woo! Look at this. A snake skin. It's a big one. Do we still have the head on there? Oh, I just broke that off, but yeah, we do. Focus in there, camera, if you would please. Thank you. That's pretty cool. It's a big old snake skin. I like it. Well, that's it for for today. Got a backpack full of fluorite. Time to head back to the truck before it gets too dark. There's another little mine started up there. I didn't get any footage of it. There's actually a pit right here, but I think you guys saw the best of it, and I'm running out of storage. So, let's make the trip back. As we go back, actually, I did want to point out we're following this little trail here, and there are all the things that we were seeing. They went up all up that way. I walked up here just a little bit ago. Pretty cool. That's kind of the main area where I left my backpack for a little bit. Very, very cool. Well, we're almost back. Beautiful little canyon here we're coming through. Should be able to see my truck once I get around this little bend. Whew! Been a good day. Lots and lots of hiking, which is nice. I need that after a week of work and school and stuff. Whew. Yep, there's the vehicle. See him over there? Now I just need to figure out how to get him turned around and out of that narrow little canyon. We'll figure it out.
All right, so let's talk a little bit about why these mines are here. I know, I'm gonna teach you something. I'm sorry, but I can't resist. So obviously, why do we mine things? To get resources. And these mines are all after specific mineral resources. In my area, the most common resources are fluorite, which in the industrial world is called fluorspar. But fluorite, copper, zinc, lead, a lot of lead mines, as well as gold, silver, things like that. Obviously materials that people want. A lot of people ask me, why fluorite? Why do people want fluorite? Fluorite is very, very important, even to this day. It's our main source of hydrogen fluoride, which is used in all kinds of different things. There's a lot you can do with fluorite. Back in the day, I think it's still used today, but I know it was more popular back in the day. It was actually used in steel making. It was used in the process of making steel. Basically, you can get the fluorite, and I'm not sure exactly how this process works. I'm not a metallurgist, but basically the fluorite helps to lower the melting point of whatever metal you're working with. And fluorite is, I think it's more commonly used nowadays in making or processing aluminum. So when you're making aluminum alloys, fluorite is used in a lot of that. So it's definitely something that we still use. Fun fact, I learned this recently. There are camera lenses that are made out of fluorite, which is very interesting. There's some optical properties that fluorite has that some artists enjoy. But yeah, that's one of the uses for fluorite. The other things I don't think I really have to explain: copper, gold, silver, zinc, lead. These are things that are pretty commonly used in all kinds of everyday items, right? So mining materials are very, very important. But how do we know where those materials are? Well, it's because a lot of the stuff these mines are going after are secondary minerals. And what this means is that these minerals are deposited secondarily to the formation of the rock they're being deposited on, in, or around. Let's explain how that happens. A mineral is an inorganic compound. It's what we call a solid solution. And what that means, the term solid solution, is that we have this amalgamation of elements that forms a solid body. But minerals can be not solid. They can exist in different forms, or at least their components can exist in different forms. Let's talk a little bit about igneous petrology real quickly. So igneous rocks are kind of, you can think of them as kind of original rocks. These are rocks that form from a magma body, right? So if you have this magma, it's a liquid rock, right? It's very hot liquid rock. And basically, it's this puddle of elements. All kinds of elements are mixed up in this soup. And when this soup starts to cool, minerals start to form. The reason minerals don't form when it's hot is because all of these elements, all these atoms are excited, they're buzzing, they've got a lot of what we call vibrational energy, right? They're moving too fast to form bonds. And so when you start decreasing that temperature, you're taking energy away, they start moving slower and slower until eventually they're moving slow enough, or not at all, that they can start forming bonds with each other. And this builds minerals. And the way it builds minerals is influenced by the type of minerals that get built. There's actually an order, we call it Bowen's. We're not gonna go into this too far, but it's Bowen's chart of Bowen's reaction series. I had a brain fart there. But anyways, we're not gonna go into that. Crystals have a definitive chemical formula and a set crystalline structure. And what this means is that minerals only allow certain elements into them. Minerals are built by stacking lattices of tetrahedrons, stacking lattices of little, you can think of them as little Lego pieces of element combinations. And so you have some minerals that form cubes, some minerals form kind of pyramid-shaped things. We're going very broad for the sake of this explanation, but they only allow certain elements into them. And so that's how elements form out of a magma body. And there are important minerals that get mined out of, especially like pegmatites. You have a lot of what we call incompatible elements. These often include rare earth elements like lithium. And so lithium is a really important mineral resource right now, right? And so basically, lithium doesn't like to fit into the crystal structure of basically anything. It's a very big, very naughty atom, you can think. But eventually, as that magma cools, if it's reaching zero, all these different elements in the magma have to go somewhere. And so all the stuff that's left over, the very last things to be put into minerals, tend to be these incompatible elements, these rare earth elements, and they typically go into things like micas. Like lithium is very, very common in a mica called lepidolite. It's also found in a nesosilicate, I think, called spodumene. Spodumene is a pyroxene, which means it's an N-silicate, not a nesosilicate. My bad. Anyways, that's an introduction to how crystals form, how minerals form. So now let's talk about the minerals that I'm finding in these mines. Fluorite I find very commonly. Fluorite mines are very, very common, but I also find fluorite basically everywhere. Almost every single mine I go in, there's fluorite. It's very, very common. And it's because a lot of these minerals are the secondary mineralization like I talked about. What we were talking about with the igneous body example was primary mineralization. That is the first formation of these minerals. Secondary mineralization happens after that. Secondary mineralization can involve the reprecipitation of remobilized mineral elements, or it can be due to metamorphism or alteration that affects a mineral, a rock, on a physical and chemical level. Let's look at our good buddy fluorite. Fluorite has a very simple chemical formula, CaF2. It's calcium fluoride. That's it. That's all fluorite is. Why do I find so much fluorite? Well, it's because a lot of the rocks around my area happen to be limestone. And limestone is basically made mainly of calcium carbonate or calcite. I said calcium, did you catch that? calcium is water soluble. So water running through these limestone rocks will dissolve calcium and carry it around and also have dissolved fluoride in it, and eventually it will redeposit it somewhere else as fluorite. How does this happen? Well, let's think a little bit about a glass of water, and it's salt water. What happens if I take this glass of salt water and I heat it up? Eventually that water will evaporate. It'll turn to a gas and it'll rise. What happens to all the salt that was dissolved in that water? It stays behind. It sits on the bottom of the cup. And if we have a lid on the cup, of course that water rises and it collects on the ceiling. It becomes condensation and eventually it'll fall again and redissolve that salt. But that's how a lot of minerals are precipitated, a lot of carbonate minerals. And when we say carbonate minerals, all I mean is a mineral that has CO3. That's a really stupid O. I'm sorry, for some reason I tried drawing an A. I thought I was writing out carbonate. But CO3, that's carbonate. It's carbon trioxide, basically. And the only difference between a mineral such as calcite and a mineral like smithsonite is the cation that goes in front of the carbonate. So for example, smithsonite is zinc carbonate. That's smithsonite. Calcite is calcium carbonate. So obviously, smithsonite is a rock that we use to extract zinc from. Calcite, we can't get calcium from. Calcite is very, very common. It's mostly an accessory mineral in a lot of these mines. Calcite, again, is even more common than fluorite. Actually, calcite is everywhere. And there are there's quite a few economical uses for calcite, but in a lot of these mines, it's mostly an accessory mineral. It's something that would mostly be discarded. But anyways, both of these rocks, this calcite and this smithsonite, started as dissolved solids in a water that were eventually precipitated out. Okay, but what's the mechanism that allows for this to happen? Well, one of the biggest mechanisms, and the one that we're going to focus on, is faulting. Faults are places on Earth's surface where there are weaknesses or cracks that rocks can slide along each other. Where you have mountains, you have faults, basically. People often know the San Andreas Fault, which is in California. It causes a lot of earthquakes. That's a transform fault. It moves like this. A lot of faults in the area that I am at, a lot of faults that host a lot of this mineralization are normal faults, meaning they move like this. A reverse fault or thrust fault moves like that. So you can think if things are pulling apart, if there's forces pulling this way, bam, you normal fault. If there's things pushing to each other, if it's compression instead of extension, if you're compressing, you might push something on top of something else, and that's a reverse fault. In my area, there's lots and lots of normal faults. When these faults slip, when they move, they crack the rock. Obviously, they cause earthquakes and can be very destructive. But what happens is it allows access for water to get down in the rock. And this, obviously, rocks are not closed systems, right? This allows the water to eat away at the rocks, erode it, weather it, and collect soluble minerals and elements from that rock. Something we were talking about limestone a little bit. Limestone gets broken down very, very easily on Earth's surface because it's susceptible to what we call carbonation erosion or carbonation weathering. And basically, the way this works is, remember, limestone is made up of a lot of calcite, CaCO3. Well, calcite just so happens to be vulnerable to being eaten away by carbonic acid. And carbonic acid is very, very common. See, our atmosphere has a lot of carbon dioxide. CO2, carbon dioxide. There's a lot of it in our atmosphere. You know what else is a lot of in our atmosphere? Water. When carbon dioxide mixes with water in the atmosphere, the carbon dioxide is dissolved into the water. And this creates something called carbonic acid. And that carbonic acid falls as rain, acid rain, and it eats away at limestone. And this weathering process breaks down these rocks. That's what weathering is it breaks rocks down. There's two types of weathering, physical weathering and chemical weathering. Physical weathering is literally just breaking a rock. Chemical weathering is taking that rock apart on a chemical level, and that's what carbonation weathering does. It breaks this rock down into basically its core parts, its separate elements, and those get mixed in with water that's running through this fault system, and eventually that can be reprecipitated somewhere else. You've often heard that water is the source of life, and it is. We have to drink water to stay alive, but water also does so much for us in so many other ways. And one of the ways is by precipitating all of these economic minerals for us to use. Humans love metals, right? We love metals. And when you have metals in the form of nitrates, chlorates, acetates, all metals are water soluble. And that means that water can move metals around a system and reprecipitate them. And that's why a lot of these mines were looking for these hydrothermal systems. And a lot of times, again, these are focused around faults. There's other ways you can get this intrusion of a magma body that heats up water that can actually help the water be better at dissolving things. But we're not going to go into all of that just for the sake of simplicity. But that's how we get a lot of our most basic metal needs, is we extract them from these minerals. One mineral that I actually don't have a piece of right now, but I might show later, is malachite. This is an important mineral for copper, and it has a little bit more of a complicated chemical formula than what we've been dealing with. It is Cu2, that's our copper. Excuse me. CO3, recognize that, that's our carbonate. And then OH3, I think. No, that should be a 2. My bad. Make sure you balance your formulas. That's a 2. So that's malachite. And that is one of our main sources of copper. So we mine a bunch of malachite, we get the malachite out of the ground, and we can refine it, we can take that copper out of it, and now we have copper. So that's why a lot of these mines are very, very important, and that's why, honestly, as a geologist, it's very easy for me to find areas that have the potential for these minerals. Even if there's no mines there already, there are lots of times where I could be walking around and say, oh, there's a big old fault system right here. Let's go look at it. Yeah, I'm finding some altered rocks here. This would probably be a good spot to dig for XYZ, depending on what I see, right? So, quick little geology lesson. I mean, that probably wasn't quick at all, but I hope you enjoyed it. Okay, but what do I actually get out of these mines? Well, here's some minerals that I have. I have a lot of rocks. I have shelves full of rocks. I have boxes full of rocks. My truck bed is full of rocks. I really like rocks. But I grabbed a couple of things off my shelves at my desk real quick to show you guys some of the things that I find. And the first thing I want to show is this kind of ugly looking rock. This is really indicative of hydrothermal alteration zones. Rocks like this are what old-timey miners back in the day would love to find. You can see here we have all of this quartz that's growing on here. This came from a copper zinc locality, so we've got a little bit of malachite in there. We have some cerussite. We've got a bunch of different minerals in here, but this is very classical secondary mineralization of a rock. This is very, very cool. Okay, next, here's a chunk of fluorite that I left on its limestone matrix. I hacked this out of a wall, and I just thought it was really pretty because you can see kind of that fluorite crust on there. And fluorite, most of the mines I go into are fluorite mines. I get a lot of fluorite. I get a lot of different minerals, but a lot of it is fluorite. There's a lot of fluorite Fluorite can be very, very cool, but the reason there's so many fluorite mines is because in the latter part of the 19th century, fluorite became really, really important for annealing steel. So there were a lot of mines dug looking for fluorite in the late 19th century, early 20th century. And then a lot of these mines were closed down, but when World War, especially II, maybe to a lesser extent World War I, but I know a lot of the mines were reopened during World War II to get even more fluorite out to help with the war effort. So a lot of cool stuff there. Here is a chunk of rock from that biggest mine that we explored in this video. And you see here we've got fluorite, massive green fluorite, and then we've got like this little top of quartz dipyramids. And I think it's really, really cool. Quartz is always a lot of fun to find if you can find it, you know, in these kind of radial, good dipyramid shapes. Here's one that I keep on my desk. You guys probably see this one in all my reviews. But you can kind of see in the cross section here the mineralization growing out. This actually came from that same mine. When I got this one, I was actually crawling on my belly through a little tunnel I don't think I got any footage of. And this was on the ceiling, so I kind of rolled over and very awkwardly used my chisel to kind of get this off the ceiling. But very, very cool. Like that piece a whole lot. Very beautiful. Let's go ahead and look at some other quartz pieces just because. I brought 3 examples out. So these are little quartz crystals that came from a mine that I didn't show in this video, but they're kind of coated in this film, I guess you can call it. And I kind of like that raw look. This one is broken, but this one still has a point. I like my rocks to look a little bit raw, but I have a buddy who does fantastic prep work. And so I gave him the biggest crystal I found at that mine for him to prepare. And this is what he came up with. So yeah, this is what they look like, all cleaned up. This one's pretty incredible. I like that one a whole lot. From that same mine, it's a copper zinc mine. I didn't grab any of my good pieces. These ones aren't great, but we can use them. These are pieces of, here's some malachite. Let's focus up. There we go. It's that green. Is this the piece? I think it is. Oh yeah. Yeah, on this side, you can kind of see more of the crystallinity of that malachite. And then got a little bit here. You can see it's a little more sparkly. Very, very cool. One mineral that I've been finding recently that I didn't used to find that I'm a big fan of is smithsonite. It comes in this blue color. It comes in a white, which I didn't bring out any of the white today, and a yellow, which I only have a couple of pieces of. But when it's yellow, it's called the turkey fat mineral, which is kind of cool. But very, very cool. Very cool mineral. I like smithsonite quite a bit. We're going to be talking about a lot more fluorite here, so let's really quick look at this. This is not the best piece, but this is actually rhodochrosite. You see that kind of pink going through there? Yeah, that's gorgeous. That's gorgeous. And yeah, let's look at some of the fluorite. So fluorite can come in a couple different forms, just like all minerals. You can have massive chunks of it where it's just a blob, basically. But that's different from a botryoidal blob, which is what smithsonite can kind of form. In fact, let me go grab a piece of smithsonite that's botryoidal. Okay, sometimes you gotta be careful about using the term blob because some people might describe this as a blob. This is a type of mineral habit that we call botryoidal, where it's kind of this bubbly texture. And this is actually not smithsonite. This is hemimorphite, but it's very, very similar. Look at that. Very, very cool. Anyways, so you can get massive crystallization, which is just like this, where it's just kind of one homogeneous body of it. But fluorite also forms in cubes. So here's a piece that, let's go ahead and bring out my light here. Maybe that'll, yeah, you can see all those cubes kind of growing together. This is actually a really, really nice piece that I found. I like this piece a whole lot. Let's see here. I have a couple of cubes that are just by themselves, but honestly, I think it's better to kind of show this off with this, with a chunk like this. You can also maybe tell that there's, yeah, there's a good view. There's a good view of all those little cubes of fluorite growing on each other. You might also be able to tell that there's a little bit of purple to this. Well, fluorite comes in a bunch of different colors. We've seen some of the green, blue, purple. I brought out this piece of purple because I want to show something else with this. Here, we'll get to that one later, actually. And maybe I'll go grab a darker piece of purple. And yellow, which here's a piece of yellow fluorite I found. You can see it's also cubic. And this is actually, I've only ever found yellow fluorite at one locality, and it's where this one's from, obviously. See if we can zoom in on this guy. Yeah. Really, really cool. Really cool. And then let's get the purple out here, because this rock here, I chose this rock because it has a couple of interesting things. So we've got a lot of barite right there growing with this purple cubic fluorite. The purple is not showing up real good on camera right now. Let me go see if I can grab a really dark piece. Okay, here we go. This is not the greatest piece, but for whatever reason, this is the one that shows up best on camera. Focus up. Something about the purple and the camera just don't get along. I don't know what it is. But yeah, there we go. There's some purple fluorite. Very, very cool. I like purple fluorite quite a bit. I already mentioned barite. Here's another big old block of, this is some fluorite. There's a little bit of fluorite there, but it's mostly barite. And barite is super, super heavy, which is really, really cool. And it forms these kind of blades, as you see there. And they can be a little bit fragile, and I have cut myself on barite a lot. And the last rock I'm going to show is this one here. This is kind of just an amalgamation of calcite and fluorite, but I really, really like this zoned pattern right here. You can see the minerals kind of growing out like that, which is really, really cool. And I could go on forever. I have tons and tons of rocks, but we're going to stop there. Well, I hope you enjoyed this video, and there will be more in the future. I've got tons and tons of footage going down on more mines. This video turned into a little bit of a science lesson, I know. So I didn't include any other footage from any other mines, but that will be coming in the future. I think this is something I'm going to start doing a lot more of. This was actually a question I posed to my channel members on what I should do with all this mine footage, and they told me, hey, make a video about exploring mines. We'll watch it. So thank you to my channel members. They're going to be right here. Really appreciate everything they do. They're really, really awesome. If you want to be a channel member, you can join by clicking the join button below. And that's going to be it for today, guys. Thank you so much for watching. If you enjoyed this video, leave it a like, comment below, and subscribe. I've been Gideon, and I'll see you in the next one.